So today, surprisingly, we have an integration question. Geometry and integration are the two things that I love the most, and so forth we will have most of the videos related to these two topics only. So there were so many days I made geometry now, so it's time for the integration problem. So basically we have to solve for this integration and there is no limit. We have to just find its value. So let us see how can we solve. First of all, let me change the color. So how we'll start the solution is let the integration be denoted by capital letter I. So let I equals to square root of 1 upon the square root of sine cube x into sine of x plus a dx. Now whenever I see this kind of pattern sine x plus a, one thing's come to my mind is this one, that I can just break it down like this way, sine x plus a minus x, because this whole thing will give a result of sine a and that is a constant, hence we can remove it. So we can just divide a sine a, so to adjust the particular numerator, and the denominator is still intact and it is sine cube x into sine of x plus a, and all of this with respect to dx. Okay, now this denominator constant can be taken out, so 1 upon sine a. Now look carefully, in the numerator we have sine x plus a minus x. I can make a pair of x plus a, and hence we can apply this particular identity that suggests us that sine of a minus b is equals to sine of a cos of b minus cos of a and sine of b. And here the role of a is played by x plus small a and the role of b is played by simply x. Hence the numerator will turn out to be sine of x plus a into cos x minus cos of x plus a into sine a. Now look carefully in the denominator, as we have a square root of sine cube x, so we can just write it down as sine x, and in the root we will have sine x, and in the same continuous root, or I can just separate the root and we will have sine of x plus a dx. Okay, now what comes to my mind now is a very drastic thing that just came to my mind, and it's the rule that when you do the derivative d by dx of something like which is in division u upon v, what we usually do is we v square v as it is the derivative of u minus u as it is the derivative of v. I don't know, but this kind of pattern just came to my mind that this can be used over here. So in the denominator we need v square, means something said that should be squared. So I can think of sine x as like sine x was previously like square root of sine x, square root of sine x, and we did the square of this particular thing. So we have got sine x. Now what to do with these two things? So I just gave these two things to the numerator. Hence we will have sine x plus a cos x divided by the root of sine x and the root of sine x plus a. Now minus, we will have cos of x plus a into sine a, and the division we will have the root of sine x and again the root of sine x plus a. Okay, dx. So 1 upon sine a as it is the integration. Now look carefully. Here what we have is sine x plus a in the numerator and root of sine x plus a in the denominator. So overall the result would come out to be the square root of sine x plus a, and it is going to be multiplied with cos x upon square root of sine x. Nice. Minus. Now here what we have is sine a. Wait, it's a mistake over here. Yes, it's going to be sine x, not sine a. It's going to be sine x. Who saw the video over there might be thinking that I made a foolish mistake, but yes, sorry, it's sine x, so forth. Here we will have sine x. Now look carefully, what we have to deal with now is the root of sine x, and the sine x will give us in the numerator root sine x, and this should be multiplied with cos of x plus a, and in the division root of sine x plus a. Nice. And all of this divided by still the root of sine x, and it is the whole square dx. Now look carefully, as I told you, what was this pattern suggesting? That whatever thing is been squared over here, that should be as it is, and with that there should be some kind of derivative. So root sine x is over here and it is going to be multiplied over here. It's not the first term but the second term, so I can just make it the first term by taking out a negative sign common. So finally, we will have 1 upon sine a and negative 1 upon sine a. Hence, inside we will have the root sine x term as first term multiplied by cos of x plus a divided by the square root of sine x plus a. Nice. Minus the root of sine x plus a, and this one multiplied with cos x upon root of sine x, and all of this divided by root of sine x the whole square dx. Now look carefully at that pattern again. Let me just write it down for you again. So the d by dx, the derivative of anything of u by v type, means v and u are function of x. We do v square, then we have v, then we do the derivative of u, minus, then we have u, and then with the derivative of v. So almost we have figured out the v over here. In our question, we have taken v as the root of sine x. So the pattern is satisfied over here and over here. It would be more satisfied if we have v dash, means this must be the derivative of root sine x. Is it true? Let us find out. So what is the derivative of square root of sine x? So it is basically going to be uh, 2 times the square root of sine x, and the derivative of sine x is cos x. Yes, it is almost the same pattern. All we need to adjust is 2. So if I just give the 2 in the denominator and just remove the 2 by multiplying, so what I can just write over there is this negative root sine x plus a as it is, and this thing multiplied by the 2 adjusted as it is, and the other thing can take the place of d by dx of root sine x. Nice, this pattern is satisfied. Now look carefully. The u that you need to find is from over here. So over here the role of u is simply played by root of sine x plus a, and if that is u, then this must be u dash, yani this particular term cos x plus a upon root sine x plus a must be the u dash. So if I considered my u as root sine x plus a, now let me check that this plays the role of u dash or not. So du by dx will simply turn out to be 2 times the root of sine x plus a, and the derivative of sine would give us cos x plus a. Yes, again the almost pattern is ready. All we need to adjust is 2 and 2. So finally what I can say is that the integration has finally turned out to be negative 1 upon sine a integration of the root sine x as it is, but inside we have 2 times the derivative of root of sine x plus a. Nice. Then minus root sine x plus a as it is, and then inside we have the 2 times derivative of root sine x. Okay, again nice. And finally in the denominator what we have is root of sine x the whole square dx. Now all of this pattern would have failed if we cannot have taken out this 2 common, because that formula of d by dx doesn't contain any kind of 2. So clearly we can take out the 2 common. Just imagine, instead of this 2, if we have got 3, we cannot use that pattern, and still as we have 2 we cannot use. We can use that derivative pattern on only when we can just take this 2 common. So if I take the 2 common, now the whole pattern is very clear, sine x, and it is getting multiplied by the derivative of root sine x plus a. Okay, and then we have minus root sine x plus a, and it is going to multiplied with the derivative of root sine x. I hope you understand this particular thing. And in the denominator we have root sine x the whole square, and at the end we have dx. Okay, so I hope you understand what the pattern I was trying to tell you. Should I explain it again? No, I think you have might got it. Okay, so negative 2 upon sine, and if you didn't understand, do comment below. In the upcoming video I can just take a few minutes and explain to you. So now we have negative 2 upon sine, and this whole pattern now can be condensed into what? It can be d by dx of u upon v. So what was u? It was played by root of sine x plus a, and what was v? It was played by root of sine x. So now what we have is a integration of a derivative, hence the final answer will come out to be that whichever function derivative is done. So the final answer would be square root of sine x plus a upon sine x, and don't forget to add the plus constant c. So this is the value of the integration I that we were trying to solve. Okay, here you can just add on few more steps, that here you have considered u as equals to root sine x plus a, and you have considered v is equals to root of sine x. Hence we already know this prerequisite knowledge that d by dx of u by v is v square upon v as it is derivative of u minus u as it is derivative of v. So as this whole RHS pattern was already ready over here, so you can just write it down in the LHS way. So we have written that, and as we are dealing with the integration and then we have the derivative, hence the answer comes out to be that derivative. So this was my way to solve this particular problem. So this was my way to solve this particular problem. If you have any other method, you can do comment below, and if it's a photo or a PDF, you can send it to me. It's 26th of April 25. Okay, so you can do comment below, and if you have any other kind of photo or PDF that you can just want to share with me, you can email me. The email is in the description. Okay, and do comment below that should I bring up more integration problem or not. I have many of them integration geometry. All is required is time from my side. so I can make, and you take out your time to watch these particular videos. Do like, share, comment, and subscribe. Thanks for watching. Bye.